Hello dear students, welcome to Toppscholars. Today we'll be discussing about factors affecting the rate of a chemical reaction. So friends, let's first discuss what do we mean by rate of reaction. Now friends, the speed at which reactants are converted into products in a chemical reaction is known as rate of a reaction. So what is rate of reaction? Yes. Rate of reaction is the speed at which reactants are converted into products. Now friends, there are some reactions which occur slowly, whereas there are some reactions which take place at a faster rate. So definitely there are some conditions, right, depending upon which the reactions occur slowly or the reactions occur fast, right? So that is what we are going to study right now. That is the factors which affect the rate of a reaction. And which are they? Yes. The first one is nature of the reactants. The second one is size of the particles of reactants, concentration of the reactants, temperature of the reaction, and finally catalyst. So friends, let's first start with the first factor, that is nature of reactants. The nature or the reactivity of the reactants is the one which influences the rate of a chemical reaction, which means that the reactivity of the reactants taking part in a chemical reaction determine the rate of a chemical reaction. So if the reactants are more reactive, the rate of the reaction increases. That is, higher the reactivity, more is the rate of reaction. Let's take an example to understand this. Now friends, I have two metals, aluminium and zinc. What I'm going to do is I'm going to react it with dilute hydrochloric acid. So these metals, when they react with dilute hydrochloric acid, it results in the formation of salt along with the liberation of hydrogen gas. But if you observe the rate at which hydrogen gas is liberated, you will notice that when aluminium reacts with dilute hydrochloric acid, the rate at which hydrogen gas is liberated is faster as that compared to reaction of zinc with dilute hydrochloric acid. This is because aluminium is more reactive than zinc, and as we said, if the reactivity of the reactant is high, then the rate of the reaction increases. So in this reaction, since aluminium is more reactive than zinc, aluminium reacts with dilute hydrochloric acid at a faster rate, and so the rate at which hydrogen gas is liberated is more as compared to that with zinc. The next one is size of the particles of reactants. Friends, remember, smaller the size of the reactant particles, larger is the surface area, and so the rate of the reaction also increases. Which means that in a reaction, if the size of the reactant particle is small, then larger is the surface area, and so the rate of the reaction increases. Let's take an example to understand this, right? So I have two test tubes. What I'm going to do is, in one test tube, I'm going to take zinc powder, and in the next test tube, I'm going to take zinc granules. Now what I'm going to do is, I'm going to add hydrochloric acid in both these test tubes. Now if you observe, the reaction of zinc powder with hydrochloric acid is faster as compared to the reaction of zinc granules with hydrochloric acid. Why is this so? This is because zinc powder, that is the reactant particles in zinc powder, is smaller in size as compared to the reactant particles in zinc granules, right? And as we said, smaller the size of the reactant particles, larger is the surface area, and so higher is the rate of the reaction. So in case of zinc powder, as the size of the reactant particle is small, the rate of reaction is more as compared to that with zinc granules, right? So what is the conclusion over here? Yes, smaller the size of the reactant particles, larger is the surface area, and so the rate of the reaction is also high. Now let's move on to the next important factor, that is concentration of the reactants. Remember friends, rate of a reaction is directly proportional to the concentration of the reactants, which means that rate of reaction increases with increase in the concentration of reactants and decreases with decrease in the concentration of the reactants. Let's take an example to understand this, right? Now again here I have two test tubes, okay? In both the test tubes, I have taken zinc metal. Now what I'm going to do is, I'm going to add concentrated hydrochloric acid in one test tube, and in the next test tube, I'm going to add dilute hydrochloric acid. Now what you need to do is, you need to just observe the rate of evolution of hydrogen gas. You will notice that when dilute hydrochloric acid is added, the rate at which hydrogen gas is released is less. But when we use concentrated acid, the rate at which hydrogen gas is released is more. So as you can see, when the concentration of the reactant is less, then the rate of the reaction decreases. Whereas when the concentration of the reactant is more, then the rate of the reaction increases. So in this reaction, we can see that when dilute acid is used, it means that the concentration of the reactant is less, and so the rate of evolution of hydrogen gas is less. But when we use concentrated acid, it indicates that the concentration of the reactant is more, and so the rate at which hydrogen gas is evolved is more. So remember friends, rate of reaction is directly proportional to the concentration of the reactants. To learn more about this topic, download Toppscholars app.